Welcome. This video is on the greatest common factor. Normally we just call it the GCF, greatest common factor. Okay, the greatest common factor of two or more numbers is the largest factor that the numbers have in common. The greatest common factor is the largest number that divides evenly into the numbers given. So remember what factors are. Factors are numbers that divide evenly into a number. And what we're looking for is the largest number that they have in common. So here's our first example. Find the GCF of 30 and 45. So let's list the factors of 30. Now if you can see the answer in your head, that's great. It's kind of good to, let's write them down and get an understanding of what they are. So let's list the factors. 30. There's 1 times 30. What else? 2 times 15. Try to go in order so you don't miss any of them. So 1 times 30, 2 times 15, 3 times 10, and 5 times 6. Now let's list all the factors of 45. And remember, you can always pause the video and work on it, and then click on play when you're ready to come back and see the result. Okay, so there's 1. You could always start with 1, and you should always start with 1. Sometimes people just start with whatever comes to their mind first, and then they end up missing one of the pairs. And if you miss one of the pairs, one of those numbers could actually be your answer. And if you miss it, then you're going to get the wrong answer. So try to go in order. 1 times 30, 2 times 15. Use those divisibility rules. You know that 2 goes into 30 because it ends in an even number. 3 goes into 30, 3 times 10. Then 5. Okay, now 1 times 45. 2 doesn't work. How about 3? Yes, 4 plus 5 is 9. 3 goes into 9, so 3 goes into that number. And then just divide on your scratch paper to see how many times 3 goes into 45. Okay, so there's 1 in 45, 3 times 15, and 5 times 9. And those are all our possibilities. So what we're looking for is the largest number that's common. Well, what's the largest number? 15. 15 is our largest common factor, the greatest common factor. So the largest number is 45, but there's not a 45 for a factor of 30. So we want to know which number appears on both sides that's common, and that would be the 15. The greatest common factor is 15 because it is the largest number in both lists of factors from 30 and 45. It is also the largest number that divides evenly into both 30 and 45. So looking at 30 and 45, maybe some people thought of 5. 5 is a common factor. It is. 5 is a common factor, but it's not the greatest common factor. All right, let's do another problem. Well, finding the GCF using prime factorization. Procedure. Step 1. Find the prime factorization of each number. If a number is a prime number, then write down the same number after the equal sign. Okay, what are we doing here? We're finding the GCF using another method. That other method was okay, but we have to have a better procedure to find it. Let's say the numbers are very huge and you can't see that the answer is 42. 42 is the greatest common factor. Well, we might not be able to see that, so we need a better method, and that's what this is. It's a proper procedure for finding the GCF. This also applies to algebra. We're going to use this same method when we get to algebra. So learning these methods now, and maybe with some problems you could see the greatest common factor without doing any work. but we still want to have a proper process. Okay. Once again, step 1. Find the prime factorization of each number. That's the tree or the division box. If a number is prime, then write down the same number after the equal sign. Step 2. Circle any prime number that appears in all prime factorization lists. So we're going to make a list out of it. We're going to list the prime factorization, and then we're going to circle a number that appears in both lists or all of the lists. Depends on how many numbers that we start with. And you can get more than one number. It is possible that 2 or more of any prime number can be common in all rows. And then we're going to multiply the common primes from one row together. This product is called the GCF. If there's only one prime factor common, then there's nothing to multiply, and that prime factor is the GCF. If there are no primes in common, then the GCF is 1. So if there's nothing common, then our answer is just going to be 1. Okay, you might want to pause, write down this procedure before we do another example. Okay, find the GCF of 12 and 18. So we're looking for the largest common factor. Now, some of you might already think I could see that without doing the work. That's okay, that's great. Great that you could do that in your head. Not a lot of people can, so that's great. But what we want to do is still, when you have an easy problem that you can do in your head, learn the proper process so when the numbers are larger, or we're talking about variables and binomial factors when we get to algebra, you will still know the proper process. So take advantage of the easier numbers. Okay, step 1. Find the prime factorization of each number. So that's the tree. I'm going to do the tree method. If you prefer the division method, that was fine. Whichever method you like. I'm just going to use the tree method here. So 12, I use 3 times 4. And then 4 is 2 times 2. 3 is prime, so that's done. Now the 18. And then just kind of put the prime factorization for each number below. I think it makes it a lot easier to work it out. So 12 is 2 times 2 times 3, and 18 is 2 times 3 times 3. So we're all done with the prime factorization. Step 2. Circle any prime number that appears in both rows. Okay, so we have a 2 in both rows. We have a 2 in this row and a 2 in this row. So you're going to circle that 2 in both rows. Not this 2, because it doesn't have another 2 along with it. It has to have a corresponding pair. So it has to be in both rows. It has to be what's common. And there's only one 2 in common. Not 2 2s, only one 2 in common. Let's see, is there anything else that's common? Oh yeah, 3. So a 3 on top with a 3 on the bottom. Now we're going to multiply the common primes together from one row. So multiply what's circled, and just look at the top row. A 2 and a 3. So that's our greatest common factor, which is 6. Multiply those numbers. 2 times 3 is 6. So 6 is the largest number that divides evenly into 12 and 18. How many times does 6 divide into 12? 2. How many times does 6 divide into 18? 3. It's the largest number that divides evenly into 12 and 18. Okay, let's do another one. Find the GCF of 28 and 42. Again, you might want to pause and then click on play when you're ready to see the solution. Okay, let's find the prime factorization. We have 28 and 42. 28, 4 times 7. Maybe you use 2 and 14. It doesn't matter. You'll still get the same result here. 6 times 7 for 42. So 28 is 2 times 2 times 7. And 42 is 2 times 3 times 7. Again, you might want to pause, make sure you work through that. And then when you're ready, click back on play. Okay, circle any prime that appears in both lists. So what can we circle? We could circle a 2. Anything else? Yeah, 7. So what's our GCF? We're going to multiply the common primes together from one row. So we can multiply the 2 times the 7. And that's our answer, 14. So 14 is the largest number that divides evenly into 28 and 42. Sometimes some people might have tried to do it in their head and just say, oh, 7. 7 is the biggest number that goes into those. And they would have been incorrect. 7 is not the greatest common factor. 14 is the greatest common factor. Okay, let's do the next problem. Oh, this is looking good. Find the GCF of 90 and 140. Let's start with the prime factorization. Ninety is 9 times 10. 9 is 3 times 3. 10 is 2 times 5. Yeah. 140. Let's see. Anytime we have a number that ends in a 0, we could always use 10. That's why we use 9 and 10 for 90. You don't have to. You could have used any other numbers. You could have used 2 and 45, 3 and 30, 5 and 18, 6 and some other number. Anyways, it's always nice. When you see a 0 at the end, you could always use a 10. So 10 and 14, 10 breaks down to 2 and 5, and 14, 2 and 7. So for 90, we have a 2, 2 3s, and a 5. And for 140, we have 2 2s, a 5, and a 7. Now, circle any prime number that appears in both rows. What can we circle? We could circle a 2, and we can't circle another 2. Can we circle a 3? No, because we don't have a 3 in both rows. How about a 5? Yes. Oh, it's kind of at an angle here, but we can make our circle, or not really circle, kind of an oval at an angle. Just do an angle there. Now we can multiply the common primes together from one row. So 2 times 5, 10. Now this got kind of a little bit weird here with the 5s. You could always write this so that this 5 would have been underneath this 5. That way when you circle, you just circle straight up and down. So we put a little note here. Write the prime number so that only the same number can be written above or below. So like these 3's would be moved over to the right because there's only a 2 below it. So you don't want to have a 3 over a 2. So you might want to write something like this. So a 2 and then a little bit of space because there's a 2 below it. And then a couple 3's, nothing underneath those because it doesn't have a 3 below. Then the 5's could be circled just straight up and down. Oh, we'll go back. Sorry about that. So a lot of times, especially in textbooks, we write it that way just to make it clear. Otherwise, you might have some oval going from a number on the far left to a number way over here on the right. It's kind of looks weird. So try to write it with the 2's in one group, and then the 3's, and then the 5's, and 7's. So space it out so you don't have to have these kind of groupings from one number far on the left to one number far on the right. Or you can just be creative with your circling. It's okay. Okay, find the GCF of 24, 30, and 42. So 3 numbers this time. Well, that means 3 factorizations. So we'll start with the 24. It's 4 and 6. Again, you might want to pause and work out the prime factorizations of the other. And click on play when you're ready to get started. 30. Let's see, we could use 3 and 10, or 5 and 6 if you wanted to. Again, doesn't matter at all. 10 is 2 and 5. 6 and 7. 6 is composite. 7 is prime, so we could break down the 6. And then write it in a list. Notice how I wrote it with the 2's first, then the 3's, and then the 5's, 7's. I put a space between this 2 and this 3. So this one has 3 2's, this one only has 1 2, this one only has 1 2. And then they each have a 3. So what can we circle? We could circle a 2. We could circle a 3. Anything else? No. This one only has a 5. This one only has a 7. We need a number that appears in all of the rows. So our GCF is 6. Let's see, is that our last problem? No, we still got one more. Find the GCF of 52 and 156. Alright, let's get started. Again, you might want to pause and work out the prime factorizations of each of these two numbers. Okay, so 52. It's even. It ends in a 2, so you can always start with 2. 2 times 26. Again, I don't know that at the top of my head. I would do that division on this slide on my scratch paper. So 2 into 52 goes 26 times. Now 26, how many times does 2 go into 26? Because it's an even number, so that's why I'm using 2 again. 2 times 13. And now do the same thing with 156. Let's see, what could we use for 156? We could use 2 again, because it's an even. The last digit is an even number, so 2 goes into 156 78 times. And then 78, I could use 2 again, because it ends in an 8. 2 times 39. 39, I can't use 2, because it ends in a 9, but we could use 3. How many times does 3 go into 39? Right, 13 times. So now write it in a row. So what could we circle? Oh, we could circle a 2. Okay, this time we could circle another 2, because there's a 2 in both rows. And that's it. Oh no, a 13. 13 we could circle. So now we're going to multiply the numbers from one row. So 2 times 2 times 13. 2 times 2 is 4. And 4 times 13 is 52. Okay, that was the last problem. And we'll see you here for the next video. So long.